There is a moon in our solar system that should be dead. It's small, it's trapped. It orbits a planet so massive that Jupiter could swallow 1,000 Earths without even noticing. And yet, this tiny moon is more geologically active than anything else we've ever found. More powerful than Earth, more violent than anything in recorded history. It has over 400 active volcanoes, mountains twice the height of Everest, lakes of molten lava the size of entire seas. NASA has studied it for decades, and the more they learn, the less they want to go there. This is Io, and this is its story. What you're about to hear isn't science fiction. Every fact in this video comes from real mission data. Voyager, Galileo, and NASA's Juno probe, which has been sending back new images of Io as recently as 2024. For decades, scientists assumed moons this small were frozen and silent, dead rocks drifting through space. Io proved them wrong. It forced researchers to rewrite the rules of planetary science. It changed what we thought was possible in the outer solar system, and it raised a question that no one has fully answered yet. If Io is this extreme, what else are we missing out there? Let's find out. To understand Io, you first have to understand what Jupiter does to it. Jupiter is not just big, it is incomprehensibly massive. Its gravitational pull is so powerful that it doesn't just hold Io in orbit, it squeezes it, constantly, like a hand crushing a ball that can never escape. But Jupiter isn't alone in this. Two other moons, Europa and Ganymede, orbit Jupiter in a perfect mathematical rhythm. For every one orbit Ganymede completes, Europa orbits twice. And for every one orbit Europa completes, Io orbits twice more. This is called orbital resonance, and it turns Io into a cosmic tug of war. Jupiter pulls from one side, Europa and Ganymede pull from the other, and Io, caught in the middle, gets stretched and compressed with every single orbit, over and over, for billions of years. On Earth, this kind of friction generates heat. Imagine squeezing a rubber ball in your hand, thousands of times a second, and never stopping. The ball gets warm, then hot, then it starts to melt from the inside. That is exactly what is happening to Io. The energy released by this gravitational squeezing is estimated to be hundreds of times greater than all the volcanic and seismic activity on Earth combined. Io doesn't have a heat source at its core like Earth does. Its heat comes from the outside, from gravity itself, and that changes everything. Every world in our solar system carries scars. Mars is covered in craters. The moon is covered in craters. Even Earth, with all its weather and erosion, still holds the ancient wounds of asteroid impacts billions of years old. But Io has none. Not a single crater. Not one. When scientists first saw the images from Voyager 1 in 1979, they were confused. They expected a battered, ancient surface, the kind you'd find on any moon this far from the sun. Instead, they saw something that looked almost fresh, smooth plains, strange, colorful patches, and volcanoes. Everywhere. The reason is brutal in its simplicity. Io resurfaces itself constantly. Lava pours out of its volcanoes so frequently, so relentlessly, that any crater formed by an asteroid impact is buried within years, sometimes within weeks. The entire surface of Io is being replaced, layer by layer, in what geologists call the fastest resurfacing rate of any known object in the solar system. Io has no geological history, no record of its past. Every chapter of its story has been erased and rewritten, again and again, by fire. But the lava doesn't just erase, it also builds. Because when that much molten rock pushes up from below and then suddenly stops, the crust doesn't settle quietly. It buckles, it folds, it collapses inward with such force that it pushes the surrounding rocks skyward. That is how Io grows its mountains, and some of them are the tallest structures in the entire solar system. Most people think of Io as a victim, a small, helpless moon being torn apart by a giant planet, a world condemned to eternal suffering by forces it cannot control. But that framing is wrong. Io is not a victim. Io is an engine. Take its mountains. The highest peak on Io, Busal Montes, rises 18 kilometers above the surface. That is more than twice the height of Everest. And unlike Earth's mountains, which formed slowly over hundreds of millions of years. Through tectonic plate collisions, Io's mountains are born from collapse. When underground lava chambers drain suddenly, the crust above them drops, and the pressure forces adjacent rock shooting upward with violent, explosive speed. These mountains don't grow slowly. They erupt into existence. And then there are the lava lakes. Loki Patera is a volcanic depression so large it would cover the entire state of New Jersey. It is filled with real, dense, churning, molten rock, hotter than anything on Earth's surface. Scientists have been watching it for decades. It still surprises them. But perhaps the most staggering thing about Io is what it gives back to Jupiter. Every second, Io pumps approximately 1 ton of material into space: sulfur, oxygen, sodium, feeding a vast plasma torus that wraps around Jupiter like an invisible ring. Io doesn't just orbit Jupiter, it fuels it. Io has an atmosphere, but barely. It is 100 billion times less dense than the air you are breathing right now. Standing on Io's surface without a spacesuit wouldn't feel like standing in a breeze. It would feel like standing in the middle of nothing. Because for all practical purposes, it is nothing. But what makes Io's atmosphere extraordinary isn't its density, it's what it does. The atmosphere is made almost entirely of sulfur dioxide, and it is in a constant state of death and resurrection. When Io passes into Jupiter's shadow, the temperature drops so fast that the entire atmosphere collapses. It doesn't thin out gradually, it freezes. The sky itself falls to the ground, blanketing Io's volcanic plains in white sulfur frost, silent and still, as if the whole world just stopped breathing. And then the sun returns. The frost evaporates. The gas rises. The atmosphere rebuilds from zero in hours. Think about that for a moment. This moon loses and rebuilds its entire sky, every single orbit, for billions of years. There is no other world in the solar system where that happens. Not one. Io was never supposed to be interesting. Scientists expected a frozen, silent rock, just another dead moon drifting in the dark beyond the asteroid belt. Instead, they found a world on fire, a world that erases its own history, a world whose sky dies and is reborn with every orbit. And here is the detail that stays with you long after this video ends. Right now, as you watch this, Io is pumping 1 ton of material into space every single second. Sulfur, oxygen, sodium. All of it gets caught in Jupiter's magnetic field and accelerates into a plasma beam, a permanent, unbroken arc of energy stretching 400,000 miles from Io directly to Jupiter. Not a metaphor, a real physical connection between a moon and its planet. Io doesn't just orbit Jupiter, it reaches out and touches it. And if gravity alone can do this to a small, forgotten moon in our own solar system, then how many other worlds around how many other stars are quietly burning, rebuilding, and reaching out into the dark right now? Io doesn't just raise questions about itself, it raises questions about everything.